Okay, everyone, in this lecture series, we're going to focus on something called physical properties. And a lot of people get weirded out when they have a discussion about physical properties and chemical properties. And please label this one as a physical property or a chemical property. Thank you for enrolling in Chemistry 151. Okay, well, if that's the case, I am here to make that a little bit easier because physical properties should not be very difficult at all. So before I go through and start talking about physical properties, I want to introduce you to a little bit of pop culture. And ta-da! Here we go. If you lived in the 1980s and early 1990s, woohoo! I mean, the greatest time ever. At least that's what they say back in the day. I wouldn't know, would I? Well, maybe I would, but I'll never kind of tell you. Well, here is Olivia Newton-John back in the heyday of doing music videos about let's get physical. And that's what we're getting ready to do. We're getting ready to get physical. But hey, I got something a little bit better. How about this? So, if you would imagine, back in the day when that music video came out, everybody lost their minds because they thought, oh my God, what kind of pornography is on the TV? Well, okay, I think we've kind of come past that point now at this moment, and I don't think that that music video is anything risque like it used to be back in the day, but here we had Olivia Newton-John singing about physical properties back in the day. She just didn't know it, but she was singing about physical properties. So we need to talk about what physical properties are. We need to go through and list a few of them that we're going to be doing in a laboratory and why they are important. That's what this lecture series is all about. So when I first start off, I'm going to have to give you a little bit of information about what's happening on the inside of a substance that's given to us in a laboratory for us to test. And when we do this, and before we go down that rabbit hole, we're going to have to touch base on something I would say very elementary, but they might be actually introducing it in middle school now. I don't know. Who knows? But it is the states of matter. So if you've taken a science course before, you would know that very often we like to talk about three states of matter. And, okay, yeah, whatever. 3 states of matter is what they teach you back in the day. But, folks, I'm going to let you in on a secret. There's actually more than 3 states of matter, believe it or not. That's something that we just got to deal with, and it's something that we have to understand. So, our very first one is going to be a solid, and then a liquid, and then a gas, and then our fourth one that we can at least mention, maybe not describe in detail, will be something called plasma. So the 3 states of matter that we're going to be focused on right now at this moment is solid, liquid, gas. And this picture is kind of giving you an idea of the states of matter. How are they organized? What does it look like if you zoomed in as close as you could zoom in? What do the particles look like next to each other? And I'll go through that in a minute. But the fourth one over here is plasma, and a lot of people just leave that one out. They don't like to talk about it, but we do have to talk about it at a certain point in time in our program, and plasma is going to be very important because plasma is actually used to operate some of the equipment that we will need in a laboratory setting. So that's going to happen, but it will happen later in the program in a completely different course, but I can at least list it now. And folks, something else I need to say is that there are more than 4 states. Solid, liquid, and gas are the 3 most common, but this plasma is number 4, and there's others that are outside of that grouping of 4. So there are more than 4 states of matter. It's just very often we drop it, we don't talk about it, we don't introduce it. It's not really relevant to what we will see in everyday, routine laboratory work, so we just leave it alone. But solid, liquid, gas, absolutely, and plasma a little bit later on. So if you get a question and it will say there are only 3 states of matter, you're going to hit false, because you know good and well there's more than 3 states of matter now, because I just told you. All right. So let's talk about these particles and how they behave at the molecule level, and what their environment is like to make them solid, liquid, and gas. All right, so if we take a look at a solid, you can see these individual little balls that are located here in this picture, and they're all like nicely organized and stacked, and they all look identical, and nothing is lopsided, and they're really, really packed, and they're really, really close together. I like to call this as like a can of sardines, because everything is squished and crammed into one little bitty case. And that is a solid. That's what these atoms are. That's what these molecules do. And these solid particles are really, really close together with hardly any empty space in between the molecules. That is the definition of a solid. This is like an OCD person's dream. That's what this is, because everything is organized. Everything is in its place, from the top to the bottom, to the left, to the right. Everything looks symmetrical. That is great, folks, because I'm that way sometimes too. I want it to look nice and pretty, and that is a solid. So that is the, I guess, description, if you had to define it, or if you had to match a definition to that term. That's how I like to think of these. So it is a can of sardines, and they are crammed and smashed into one little space, and there's hardly any room to breathe at all. I will often call this like, this is New York City, skyscraper heaven, concrete jungle. This is like Miami, concrete jungle, buildings touching the sky, everything crammed in together. And you know, sometimes particles like that, I mean, yeah, let's go and live in New York City, and let's go buy a pack of toilet paper, and let's take 1 hour to get onto the subway trains and go to the place that I'm going to get the toilet paper from, and let me buy it and then lug it back onto the subway, and then another hour I'll be home. Okay, yeah, for some of you, that sounds like a wonderful life to live. Others, though, not so much. And particles are very similar. Some do really like this solid state, and that's what you will often see as a solid, of course, at room temperature in our laboratory setting. So that's how these particles are. That's just how they've grown up. That's what they know. That's how they've lived their life, and they'll continue to live their life that way from that moment on. So under the solid, it says, the molecules that make up a solid are arranged in a regular, repeating pattern. They are held firmly in place, but can vibrate within a limited area. All right, so, okay, well, never been to New York City. I've never been to Miami. I've never been to a big city. I've grew up here in Wilmington. What does that mean to me? I don't know what you're talking about. Okay, well, think of Wilmington as like downtown Wilmington. That's what a solid particle is. Everything kind of nestled together from block to block, space to space, everything crammed on top of each other, everything from retail businesses to apartments and everything else. It's all centralized in one area that's somewhat organized, I guess, if you can say that, but everything is really close together. So for some people, they're going to be like, no, sorry, absolutely not. I will not live in New York City. I'm moving out of here like everybody else. Or I'm never going to go to California, or I'm never going to go down to Miami or live in a big city, period, point blank, no matter what state it's in. Okay, well, we have options for you, and you could, if you wanted to, go out in the suburbs. Okay, now we're talking suburbs. Woohoo! Yay! Well, that's a liquid, and what I mean by that is that you are still kind of close together. Houses are to the left and houses are to the right, and with the liquid state of matter, you will see there's a little bit of empty space in between them. They are not stacked on top of each other. It is not a can of sardines. And this empty space, well, sometimes there's a lot of empty space, and other times not so much. So it's not really ordered. It's not organized. It's not symmetrical. It doesn't look kind of the same from top to bottom to left to right. All of these particles are there, but they are a little bit looser. They are a little bit more comfortable in breathing or going outside in their yard and not being harassed by people on the street. I mean, that's kind of what this liquid environment is all about. So if we take a look at the definition of a liquid, it says it's the molecules that make up a liquid flow easily around one another. They are kept from flying apart by attractive forces between them, and liquids assume the shape of their containers. All right, so basically what that's trying to say is that these liquids are close together. They touch, so they're not just by themselves. They've got neighbors that they can rely on. They've got neighbors that they can depend on. But they are not crammed in one little bitty tight space. They've got a little bit of wiggle room where they can flow over top of each other. So they can kind of move, and they can kind of go where they want to go, and they don't really have to be sandwiched into the same spot every single day of their life. So for some of you, that might sound a little bit better. You're living in the suburbs, you're not living in the cities. All right, well, if that's the case, some of you are going to look at this and say, well, you know what? Okay, liquids, they're there, they touch each other. You've got neighbors, but the neighbors are really close. I've got a little bit of space, but not too much. What if I want to go out in the middle of nowhere? Okay, well, atoms are the same way. Molecules are the same way. And that would be our state of matter that we call a gas. So with gas molecules, I will often say, they hate everybody. And I'm almost to that point in my life. So if you go out and you're like, no, I will never live in a city. I will never live in concrete jungles. And then you go to the suburbs and you're like, no, absolutely not. This is like maybe a retirement community and you will never find me in the suburb. I am not that kind of thing. Well, there are other options that are out there, and the other options is out in the middle of nowhere. And for some people, that sounds excellent. So if that is you, that is okay. Because what's happening here is that these molecules, if you look at the way that they're structured, they do not touch each other. They really do not have any neighbors at all. So they are out in the country. They are out in the middle of nowhere, and they love it. They go up their 1 mile driveway that's lined with trees, and they go to their house that's in the middle of a, forest maybe, with nothing else around them, just privacy and open air, and that is it. So for some of you, that sounds great. And for gas molecules, that sounds great too. Because again, they hate everyone. And they want to get away from everyone as much as possible because they know that's where cray-cray lives. All right, so these gas molecules, they are far apart. They do not see each other. They do not come in contact with each other most of the time. And they are free to go everywhere they want to go because they've got so much room to dance and play in. That is the gas structure. And if you look at the gas definition, it says the molecules that make up a gas fly. Ooh, doesn't that sound nice? Fly in all directions at great speeds. They are so far apart that the attractive forces between them are insignificant. All right, well, attractive forces. We keep talking about all of this attractive forces, and we need to talk about what that actually means. We need to define what an attractive force is all about. Well, okay, if I look at plasma, it says, ooh, at the very high temperatures of stars, atoms lose their electrons. The mixture of electrons and nuclei that results is plasma state of matter. Blah, 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 blah. That's what I kind of hear when I read that definition. So we are going to hold off on this. I've got a Tracy version of a definition for plasma that you'll learn more about later on. But for now, I'm just saying, hey, plasma's out there. There's more than 3 states of matter. This is one example, but we're going to ignore it for now, and we'll come back to it a little bit later. As you can imagine, these states of matter are all connected in some form or fashion, and here is how they are connected. So we start off with a solid ice cube that we take from the freezer, and the solid melts, and it melts into a liquid. Oh, go figure. That's something that we knew when we were little, right? Nothing new here. And then a liquid can evaporate, and it can evaporate into a gas state of matter. All right, well, we kind of knew that too. Hot summer days, take like a little kiddie swimming pool outside and fill the tub full of water. And then, in a day or 2 days or 3 days, you're going to go back to that and there's going to be less water in it. And that's because that liquid is evaporating into a gas phase. All right, well, that gas thing can condense. And when it condenses, it can go back to a liquid. And then from that liquid, we can put it into the freezer and we can freeze it and go to the solid state of matter. So these terms are going to show up. I'm going to go ahead and give you a warning. Warning, 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 warning. They're going to show up. And when they show up, you've got to be ready for them because it's going to say, when a liquid changes to a solid, what's the process that's going to happen? And then you go through that multiple choice question and you figure out which one is the most appropriate answer for that question. So be familiar with the terms. They are important because we do use them. Now, what could be new is up here in the top, and up here in the top, it's the ice cube again, and the ice cube solid state of matter, solid states can actually go directly to the gas phase. If that happens, we never see a liquid middle state. It goes directly from solid to gas. So we can heat up a solid, and as we heat a solid up, it skips the liquid stage, and it goes straight to the gas stage. So this is like, all my life, I grew in the concrete jungle, and I've always been in the middle of the city and the hustle and bustle of it all. And you know what? I'm angry and I'm mad. I'm not going to go to the suburbs. I'm going directly to the farmland, out in the middle of nowhere. That's where I'm going to go, the exact opposite of where I've been. Okay, well, that's great because a solid can go to a gas for the same reason, and that is called sublimation. So a solid can sublime or undergo the process of sublimation in order to make a gas. And people out in the farmland, they might be at some point in time like, I'm tired of the country living. I'm tired of going out and scraping up horse poop and feeding the chickens at 5 o'clock in the morning. I'm going to go to the city. So, okay, that's great. You can go from the farmland all the way to the concrete jungle if that's what you want to do. And if you do that, that process is called deposition. And if you look at that word, you can see the word deposit. So a gas can deposit a sample that is a solid, and we get a change of matter for that reason. So a gas is depositing to make a solid, or deposition. The process of deposition is going forward. Depositing out on the street or out on the sidewalks, that's a different story. That's a different definition. Ask San Francisco about that. But here are the 3 states of matter: solid, liquid, gas, and all how they are connected from one point to the next. All right. So when I end this video, I'm going to say, keep in mind that the whole process of learning about these tests that we're getting ready to talk about is that these states of matter have to change. And when we change these states of matter, we need to interrupt what we call the molecular forces. And we need to talk about what these forces are that we're trying to overcome. And that's what we're going to do in our next video. So for a solid to go to a liquid, we've got to disrupt the molecular forces that are present. For a liquid to go to a gas, we have to disrupt the molecular forces that are present. I want you to think of the molecular forces as the glue that holds everything together. That's what this is all about. So the glue is keeping the molecules together, organized, or together but loose. And there's even forces in a gas molecule, not a lot, but there's even forces that are there in some form or fashion that we can talk about. But in order to go from one state of matter to the next, we have to overcome and pull apart the glue that holds these molecules together with each other. So in the next video, we're going to talk about what some of this glue might be. We're going to talk a little bit about the atom, a little bit about a molecule, and some of the things that we can take away from the intermolecular and intramolecular forces and the descriptions that I'm going to be providing you during that time. So don't walk away. I know you're entertained. I know you're engaged. I know you love watching these videos, because who doesn't? I mean, it's a great great way for you to make fun of me in the privacy of your own home. And guess what? I would never know. All right, so in the next video, I'll see you then.